Hello everyone. The objective we're going to be learning about today is dealing with stoichiometry. So I want you to start with this stoichiometry warm-up. What I would like you to do is pause the video and do the calculation. The mole island is given in the bottom of the slide in case you need a little help to remember how to do this. And then once you have an answer, go ahead and re-hit play and I will go over the answer with you. Okay, so now you should have an answer for the problem. I'm going to go over it with you. The information that is given is 5 grams of silver nitrate, and what we're looking for is how many grams of silver chloride will be formed. So we're starting with 5 grams of silver nitrate, and remember to convert from grams to moles, we use the molar mass, which is 169.83 grams of silver nitrate in 1 mole of silver nitrate. Now our grams of silver nitrate cancel out and we're left with moles of silver nitrate. From the reaction, we see we have 2 moles of silver nitrate to 2 moles of silver chloride. So then we use the molar mass of silver chloride to give us our answer. So when you calculate that out, you should get 4.22 grams of silver chloride. So our objective today says I can use the molarity of a solution to solve different solution stoichiometry problems. So now we're going to take what we already know about stoichiometry and apply it to what we know about solutions. So solution stoichiometry is just calculations involving chemical reactions like we've done before in the past, but now they're going to take place in solution. And remember, balanced chemical reactions are written in terms of moles of reactants and products. So this reaction means 3 moles of sulfur added to 2 moles of iron gives us 1 mole of iron 3 sulfide. So remember, molarity, which we learned about yesterday, relates moles of solute to volume of solution. So if we know the molarity and the volume of a solution, we can figure out the moles of the solution. So we will use this instead of mass and molar mass to find moles. So here is a short example problem. We want to know how many moles are in 15 milliliters of 0.76 molar KCl. So our given information is 15 milliliters of 0.76 molar KCl, and what we're trying to find is how many moles of KCl. So remember, when we start with molarity, or when we're using molarity, the volume needs to be in liters. So the first thing we're going to have to do is take our 15 milliliters and convert it to liters. And we do that by dividing by 1,000, or 1,000 milliliters in 1 liter. So now milliliters cancels out and we're at liters. And now we're going to use the molarity to figure out how many moles are in this solution. And remember, molarity is equal to moles over liters. So we're going to use that as our conversion factor. In 1 liter of this solution, there are 0.76 moles of KCl. So liters cancel out and we're left with moles. So when you calculate that, you should get 0.011 moles of KCl. So now here we have a new mole island. We still have our grams of substance A. You could still be given grams of a substance, and you will convert that to moles of substance A. Now we have volume or molarity of a substance, and we can use molarity to calculate moles of substance. The volume we had on our previous mole island was volume of a gas. This mole island is volume of a solution. So in order to convert from volume to moles, we need to use our molarity. And then this is the same thing when we have a chemical reaction. We're going to go from moles of substance A to moles of substance B using the mole ratio that you'll get from the chemical equation. And then once you have moles of substance B, you can either convert to grams of substance B or volume of a solution of substance B. There are several different ways that these problems can be given. Example 2 says silver nitrate is added to 25 milliliters of a 0.5 molar KCl solution until no more precipitate forms. Remember, precipitate is the solid that can form during the chemical reaction. And we want to know the mass of AgCl, or that precipitate that will be formed. So our given information is 25 milliliters of 0.5 molar KCl, and the question is asking us to find the mass of silver chloride that's going to be produced. So we always want to start with our volume if a volume is given. So 25 milliliters. And remember, again, with molarity, we need to make sure we're in liters, not milliliters. So you want to divide by 1,000. And then we're going to use our concentration, the 0.5 molar KCl, which is equal to 0.5 moles of KCl in 1 liter of KCl solution. Now we're going to use our mole ratios that come from the equation. We have 1 mole of KCl to 1 mole of silver chloride. And now the question is asking us to find a mass of silver chloride. So we're going to use the molar mass. In 1 mole of silver chloride, there are 143.35 grams of silver chloride. So if we go all the way back to the beginning here, you can always check your work to make sure you're doing it correctly. Milliliters will cancel out, liters will cancel out, moles of KCl cancel out, then moles of silver chloride cancel out, and we're left with grams of silver chloride, which is what we want. So when you calculate this out, you should get 1.79 grams of silver chloride. Another type of problem that can be asked is it can give you a volume and a concentration of one solution, and then a concentration of a second solution, and ask you to find the volume of that solution. So here in example 3, it says what volume of 0.5 molar KCl is required to react away all of the silver ions in 45 milliliters of 0.3 molar silver nitrate. So the given information is 45 milliliters of 0.35 molar silver nitrate. And what we're looking for is the volume of 0.5 molar KCl. So again, you're going to start with your volume, the 45 milliliters of silver nitrate. And again, we need to convert that to liters. So again, divide by 1,000 milliliters. Okay, now we're at liters of silver nitrate, and there are 0.35 moles of silver nitrate in 1 liter for this solution. So liters cancel out, and we're at moles, where we use our molar ratio from the reaction. So we have 1 mole of silver nitrate for every 1 mole of KCl. So now we're given the concentration of KCl, and we want to know what volume we would need for that. So moles is going to go on the bottom. It's going to be 0.5 moles of KCl in every 1 liter of KCl. Right? So when you calculate that out, you should get 0.0315 liters of KCl. So you can leave that in liters, or you could multiply it by 1,000 to get milliliters, which would be 31.5 milliliters of KCl. Either way is fine. It's whatever you prefer. You can leave your answer in liters, or you can convert it to milliliters. A question could also give you the volumes of 2 different solutions of both of the reactants and ask you to find the limiting reactant. So for this type of problem, you would need to do 2 calculations in order to find the limiting reactant. So the problem says, how many grams of silver chromate will precipitate when 150 milliliters of 0.5 molar silver nitrate are added to 100 milliliters of 0.4 molar potassium chromate? So there's a lot of information here for you, so the most important thing for you to do before you just get started is make sure you understand what's given and what the problem is asking you. So the first piece of information that is given is 150 milliliters of 0.5 molar silver nitrate. So we have 150 milliliters of 0.5 molar silver nitrate. The problem also gives us 100 milliliters of 0.4 molar potassium chromate. So 100 milliliters of 0.4 molar potassium chromate. And what we're looking for is grams of silver chromate. So grams of silver chromate is what we're looking for. So we're going to do 2 calculations. One that starts at volume of silver nitrate and goes to grams of silver chromate, and another calculation that starts at milliliters of potassium chromate and then also goes to grams of silver chromate. So our first calculation starts with 150 milliliters of silver nitrate. Okay, and our first thing to do is convert to liters, dividing by 1,000. Okay, so then we're going to use our 0.5 molar concentration of silver nitrate to go to moles. So there are 0.5 moles of silver nitrate in 1 liter of silver nitrate. So liters cancels out and we're at moles. Then we're going to use the molar ratio to go to moles of silver chromate. So using the molar ratio, there are 2 moles of silver nitrate for every 1 mole of silver chromate that react. Okay, so I've run out of room, so I'm going to continue my calculation down here. So now moles of silver nitrate have canceled out, and we're at moles of silver chromate, and we're going to use the molar mass to convert to grams of silver chromate. And that is 331.74 grams of silver chromate. And then moles of silver chromate will cancel out and we'll be left with grams of silver chromate, which is what we want. So that will give us 12.4 grams of silver chromate. But that's just one calculation, so now we need to do our second calculation, which starts with 100 milliliters of potassium chromate. So again, the first thing we need to do is convert to liters by dividing by 1,000. So milliliters cancels out, we're at liters. Then we use our concentration of potassium chromate, which is 0.4 moles of potassium chromate in every 1 liter of potassium chromate. So now we're at moles of potassium chromate, and I've run out of space again, so I'm going to continue down here. And there is 1 mole of potassium chromate, that's from the reaction, for every 1 mole of silver chromate. Okay, so now moles of potassium chromate cancel out, and we use the molar mass of the silver chromate Right, so when we calculate this out, we get 13.3 grams of silver chromate. Okay, so now we've done our 2 calculations. So using 150 milliliters of 0.5 molar silver nitrate produces 12.4 grams of silver chromate. Using 100 milliliters of the 0.4 molar potassium chromate produces 13.3 grams of silver chromate. Okay. So the most silver chromate that can be produced is the 12.4 grams of silver chromate, and that was produced using the 150 milliliters of 0.5 molar silver nitrate. So 0.5 molar silver nitrate is our limiting reactant for this problem. So now I've gone through several example problems with you. I want you to work through the 2C practice problems, work in your groups and help each other if you need help. If you want to go back and watch any of this video again, feel free to go ahead and do that. And we will go over the answers tomorrow. The answers are also in your packet, but if you have any questions, we'll go over them tomorrow. Thanks.